Welcome back to Litmus Test. Ba-da-da-da-ba-da-ba-bee-boo-boo-ba-boo-ba. All right, there's our theme song, guys. Welcome back to Litmus Test. Today we've got explosives, we've got some fire, and we're going to be looking at spontaneity with explosives from our nice little villa. Looks like we're going to go away from the villa. So if I take this flint and steel, and I come way over here, and I light this wood on fire from an earlier attempt, and I just go plunk, set it on fire. There we go. It catches on fire. And we had to do a little bit of work. I had to click really hard. I had to click to set that up. But once I've set it up, it goes on its own. Take a look at that. It's spreading on its own. It's spontaneous. It goes on its own. Even though, yeah, we did take a little bit to get started, we still say it's spontaneous because it spreads on its own without us having to do anything. So a spontaneous reaction or a spontaneous process is something that happens on its own. What else can we say about this? Well, we know that fire is destructive. Take a look, all the stuff is going away. Oh, we also know that it's hot. If I step in it, it hurts me. And it gives off light. We can see it. And we'll see that at nighttime, that it gives off light. So it gives off heat and light. Energy goes down, and it's destructive. Great. Take a look at this. When I hit this, I have to do a little bit of work to break the obsidian. But after that, the water cools the lava off spontaneously. We don't have to do anything. What happens? Well, the liquid turns into a solid, so everything becomes a little bit more organized. But we can assume that the water is absorbing energy from the lava, and that the obsidian is probably still hot. So in either case, in both cases, we saw energy go down, and we saw, well, in one case we saw entropy go up, and in the other case we saw entropy go down. Now, if you remember from the last video, entropy is this idea of organized versus disorganized. Let's take a look at this incendiary explosive and see what it does when we set it off. Now it goes off spontaneously. We don't have to do any work to make all of that happen. We see that it sets off lots of fire. Well, okay. So in general, we can say that explosives will decrease energy because eventually all the stuff there goes down, all the heat and light comes out of the fire, and it increases entropy. It increases disorder. It destroys things. Let's take this one step further and look at exothermic explosives. We've got some oil right here. You can see it flows. So I figured maybe we'll try this. Now, if you think about the word exothermic, let's see what it means. Thermic, of course, means like heat, and exo, like exoskeleton, means outside, so heat going out. In other words, heat is leaving the area that is being affected and going elsewhere. Energy is going down. I don't know why I turned into the night. I should have that forward. But you can see straight away, look at all of that. There's fire everywhere. Like, everywhere. Everywhere. That's just kind of everywhere. Totally everywhere. Right. So now we've got fire everywhere. Everything is destroyed. We can see that it's giving off light. We know it gives off heat as well. If you imagine in real life, this place would be really, really hot. It'd be terrible to be in. It's destroyed everything. So entropy is increasing. Like, all the grass is gone. Lots of stuffs. But what if we reversed everything? I've got some endothermic explosives here, and while they don't exist in real life, let's see what they do in Minecraft. Because they're spontaneous. As soon as we set them off, they go on their own. Now, they only work at night, but that doesn't matter. That doesn't matter. So, endo is the opposite of exo. If exo means outside, like exoskeleton, endo must be inside. Thermic still means heat, so take a look. Heat going in. It's absorbing the heat. And this is a great visual because you can see it's just coming out and absorbing the heat of the flames. Poof, done, absorbed. Take that, flames. So everything is absorbed. All that heat is absorbed, which means that the stuff gets cold, or at least we feel cold when we touch it because it's absorbing heat out of us. So we feel cold because it absorbs our heat. The ice isn't actually cold. The ice is perfectly fine. But there is a certain amount of entropy increased, right? Everything is now solid crystalline ice. All right, so for some reason, entropy went up and energy went down. Very strange. Let's take a look at just how this all works out with a really convenient transition right there. All right, good timing. I've got the square, and this square shows energy and entropy, and I've put little examples down of what is spontaneous in every case. In this first column, we've got energy going down. Stuff is hot. And in the second column, energy goes up. Stuff, it absorbs your energy, so it's cold. In the first row, we have entropy going up. Stuff is being destroyed. It's moving from solid to liquid or solid to gas. And the second one is entropy going down. Things are being frozen and organized and such. So we start here with fire, because that's the most familiar. Fire is hot, obviously. Energy decreases because it's being given off. And entropy goes up. That's spontaneous. But there are other cases of spontaneity. Other cases like lava. Lava, when it freezes to obsidian, it gets lower entropy. Everything is crystallized. It's still hot, though. When it gives off the energy to freeze, water melting goes the other way around. And ice is kind of our example of freezing, although it doesn't seem like it. But if you think about it, energy is being absorbed, and when you touch it at least. And when water freezes, it seems like it fits in. Even it technically doesn't. But when water freezes, it crystallizes, so it's in that entropy column. Let's fly over here and actually take a look at what all that means, because just seeing examples doesn't really help. We saw fire already. We saw how it releases energy and increases entropy. Take a look at this. When it's really cold out, water will freeze on its own. We don't have to do anything. I'm not doing anything. It's just cold, and the water's freezing. The air is absorbing energy out of the ice, and it freezes, out of the water, and it freezes to ice. The entropy goes down because it's freezing, and the energy goes up. It's being absorbed. Well, it's being absorbed by the air, that is. It's a kind of good process. But it's similar to the lava freezing. The water is giving off energy, but the entropy is going down. In our case, the air is absorbing that. In the case of the endothermic explosives, we actually saw absorbing energy. In the case of the ice, we don't really see it absorbing the energy. It's the same as this lava. It's just that, well, lava and obsidian are hot things. At least when obsidian is first created, it's hot. And so we see that the energy is being released, it's going out of the lava, and the entropy is decreasing as well. Things are being crystallized. So the only case that really isn't spontaneous is the one of the endothermic explosives. If I were to set this tree on fire, everything would go off just as we'd expect. If we put water out in the cold, or if we put lava in the cold, it freezes. So entropy goes down and energy goes down as well. And if we were to melt water, like we'll do here, if we were to melt this block of ice, then it's absorbing energy, and great. It absorbs energy, entropy goes up. So what about that last case, where energy is absorbed and entropy is decreased? Well, wait till next time when I explain how Elsa's power from Frozen is the best power to have. Thanks for watching.